same one. Awesome. And like I said, if you got different colors, that might help. A highlighter. Oh, it's all over that one. Which ones did you open it down? Which ones did you open it down?
Oh, wait.
Like they should all open up.
Sorry, bro.
They should all be used.
Eeny.
They should all be used. All right, now as you take a look, like y equals x squared, this first one. Okay, this should be your y values, 41014, because when you plug in -2, you have to put that in parentheses and get back +4. Negative times a negative is a positive. That is our base function. This is basically what everything we're going to compare to today is y equals x squared. And when you graph that one, okay, that was this first one right here. Okay, vertex is at 0, 0. And that's going to be key for a lot of these, is where is the vertex? The vertex is the highest or lowest point. Okay. The second one, which I have in pink, reddish, red or pink, you should have 1, 4, 2, 1, 3, 0, 4, 1, 5, 4. Okay, so you're plugging in, it's in parentheses, so 1 minus 3 is -2, but you square that, you get back +4. So B is reddish. Right there. The first one, A, is that one. Which one is C? X squared plus 5. Okay, that is C there in yellow. And then D, my green one, x plus 1 squared minus 4. D. All right, what's the vertex? Either looking on yours or looking up here on mine for the very first one, A. What is the vertex, the coordinates of that? Okay. All right, as you take a look at that, just to make sure we're on the same page here. John, what's the coordinates for the vertex of A? 0, 0, good. It would be right there, that one right there. So that is 0, 0. What are the coordinates for the vertex of B? As you take a look at that one, which is the red one. What are the coordinates of that one? Either on your paper or up here. Okay, what do you got for it?
3, 0.
3, 0. So I'm just going to put that at the bottom. That's your vertex. How about for C? What's my vertex for C? Styles?
5, 0, or 0, 5.
0, 5. Okay. What did you say, 0, 5?
Yeah.
0, 5 would be correct. And how about that last one? Vertex for that last one. All right, take a look at that one. Ashton Martin, what do you think?
-1, -4.
It says -1, -4. All right. All right, so -1, -4. Good. Now, if you take a look here. All right, how do you compare? Hold on here. All right, how do you compare graph A and graph B? How has graph B different? How has it been moved?
To the right.
To the right, how far?
1. Never mind.
3 units to the right, isn't it?
Yeah.
Okay, so if you look at the graph for A is f of x equals x squared, right? That's the graph for A, or the function. What's the function for B? It is f of x equals what? Or is it y? I'm not sure. All right, so it's y. They're both y. What is the equation for B? Angelina, help me out. What's the equation for B?
Y equals x minus 3 squared.
X minus 3 squared. All right, so look at the equation. So you're going to need to be able to look at the equation and tell me how it changes the graph. So B shifts it to the right 3 units. What happens for number 3 there? How do you compare graph A and graph C? How's graph C move?
5 units up.
Move 5 units up. Okay? So C is shifted 5 units up. Now, if you take a look again, A is y equals x squared. B is y equals, what is it, x squared plus 5. So notice the difference. If you put a parentheses, which way does it shift it? It moves it left and right. If you just put a number at the end, which way does it move it? It moves it up. All right, how is graph A and graph D related? Or how has graph D been moved? How has graph D been moved? It's been moved to
4 units down, 1 to the left.
4 units down, 1 to the left. So D is shifted left 1 unit, down 4 units. Doesn't matter which way you do it. But now take a look at the graph for D, or the equation. It's y equals x plus 1 quantity squared minus 4, correct? So the number in parentheses is going to move it which way? Move it left and right. And then the number outside is going to move it up or down. What we're going to do today is this section is we take a look at how to shift these graphs and how the equation can be altered to change it. All right, now go to that second page I gave you. Okay, go to that. Okay. To make a graph wider or narrower, okay, so everything is going to be compared to x squared. So this is y equals x squared. What is the a value for that one? The a value is just what? It is just 1. If you put a different number in front of there, like you make it y equals 2x squared, or you make it y equals 0.4x squared, it's going to change its width. It's going to make it wider or narrower. Okay? So it determines what direction it opens, but it also determines how wide it is or how narrow it is. Okay? So right here, the graph of f of x equals ax squared is narrower than the graph of x squared if this a value is bigger than 1, the absolute value. Or it's wider if the absolute value is less than 1. I'll try to explain that in a little bit. All right, the red one is x squared. 1/4, that value is smaller than 1, so it's going to be wider. -2, you take the absolute value. Really, just look at the number. Ignore the sign. Look at the number. If the number is bigger than 1, it's going to be narrower. So these are cases that will be narrower, like f of x equals 3x squared. F of x equals -4x squared. F of x equals 10x squared. As long as that number, ignore the sign, is bigger than 1, it's going to be narrow. All right, when is it going to be wider? When numbers less than 1 is between 0 and 1. So these are narrower. Wider will be like f of x equals 1/2 x squared. F of x equals 2/3 x squared. F of x equals -0.2 x squared. Doesn't matter if it's negative. Just it'll open down, but it'll still be wider. Okay. So we want to talk about how we move it left and right and how we make it narrower and wider. Okay, so right there, if you take a look, which is narrower between those two? And I'm just going to say f of x equals 3x squared or g of x equals 0.5x squared. Let's see if we're making sense here.
3x squared.
3x squared has to be narrower, so circle that one. The bigger the number, the bigger the a value, the narrower the graph. So a is 3, a is 0.5. The closer the number is to 1, the wider the graph. Okay, the wider the graph. So here, let me just do this real quick. I can do this a little bit easier than you can. So y equals, if I plug in x squared, okay, and I hit graph, looks like that. If I want something narrower, I just need to put a number in front of there that's bigger than 1. So if I put 3x squared, okay, it's going to be narrower. What would be one that's wider than x squared? What do you think?
1/4 x squared.
1/4. I'm just going to make it 0.25 x squared. And if I hit graph, now if I want something wider than 0.25, I get closer to 1. What if I did 0.1 x squared? And that's going to be even wider, okay? So you can just keep continuing to do that. So that number affects how wide or how narrow it is. All right, how do we move it up or how do we move it down? So if you take a look here, vertical shifts. Okay, if you tack on a number, let me go here. 2x, whoops, hold on. And then we got x squared plus 5. Instead of starting at 0, 0, where does it start at? It moves up 5 units. So what that does is that's going to move it up 5. So for this one here, your vertex is 0, 0. What's your vertex here for this one? 0, 5. So write that on there. So indicate what the vertex is. That's going to be important. That's going to be important. All right, now go to the one right below it. You got to watch how this is organized. Go to the one that's right below it. All right, what is the equation it gives us for that one? Is it x squared minus 3? All right, what's that going to do to the graph? So if I make this minus 3, it's going to shift it straight down. So now where is this vertex at? Its vertex is at 0, negative 3. So to shift it up, you add a number at the end. To shift it down, you subtract the number at the end. So that's how we move it up or down. To make it wider or narrow, you put a number in front. Okay. Horizontal shifts. Okay, I want to move it left or right. This is where we have to do parentheses and put the squared on the outside. That's a little bit backwards. Because if it says x minus 3, because sometimes you think negative 3, negative 3 is here to the left, but it actually shifts it the opposite direction. Just take a look at this here. If I go y equals parentheses x minus 3 squared, it's going to move it to the right. All right, what is its vertex? Its vertex is 3, 0. Okay, vertex is 3, 0. And now if you move straight down below there, if you put x plus 5 squared in parentheses, it's going to move it which direction? It's going to move it to the left. And so it's going to have a vertex of negative 5. Negative 5, 0. Okay, for that one. All right. Now take a look at those. I just want you, what would the sketch look like for this one? Where would the vertex be? Let's see if we can figure this out. What does the x minus 1 in parentheses do to the vertex? Which way does it move it? Moves it right. After the parentheses move it left or right. And it's actually the opposite. So if it's x minus 1, it actually moves it which direction? Right. It's going to move it right 1. And then where's the plus 2 going to move it? Up 2. Now it's moving the vertex. So now where is it at? It usually starts where? It's just for regular x squared, it starts at 0, 0. So now where is it at? It moves right 1 and up 2. So put a dot right there. Now we could plot some points just to kind of get an idea, but I'm just going to graph it right like that. And it's going to be the same width as the normal one. Okay, so all I want to know is which way it opens and where the vertex is. So the vertex is 1, 2. Okay, this negative out in front, that's like a negative a value. And what does a negative do on the x squared? It makes it go which direction? It makes it go down. The negative on the a value makes it go down. All right, the x minus 2 moves the vertex which way? Let's see if this is sinking in at all. Aiden, any ideas for the x minus 2, which way it moves it? Right, how far? Good. Moves it to the right 2. Emily Niermeyer, what does the plus 1 do? Moves it up 1. Good. So our vertex is 2, 1. So I put it down there. All right, now which way, since you have that negative there, that makes the x squared negative, so which way is it going to open? It's actually going to open down. It's going to be the same width as x squared. It's going to open down. Okay, so we got that. All right, x minus 2 squared plus 1. All right, x minus 2, Michael Cronin, what do you think that does? Well, the negative makes it opens down, but which way, what does the x minus 2? It moves it one direction. Does it move it left or right or up or down? Okay, the parentheses, move it left or right, okay? Like right here. These, whatever's in parentheses, that tells you how far it goes left or right. Whatever's on the outside, the plus 2 or the minus 1 or whatever they have, that moves it up or down. Okay, that moves it up or down. So here, if you got x minus 2 squared, which way is it gonna move it? All right, it's gonna be the opposite of the sign, whatever's in there. So it's gonna go
To the right.
It's gonna go to the right 2. John, how about plus 1? What's that gonna do?
It's gonna go up 1.
It's gonna go up 1. So that means your vertex is gonna be the point 2, 1. Now the negative in front of the 1/2 opens it down. The 1/2 is like the number in front of the a. Is it gonna make it wider or narrower? It's gonna make it wider. So it's gonna open down and it's gonna be wider. Now for this part right here, I'm not totally concerned with getting it too exact. Okay, for that. All right, I want to kind of do this together, the left side. Hold on, keep that stuff in front of you though.
Braden doesn't really.
It would be awkward.
All right, we're just gonna go down the left-hand side just to kind of make sure we are on the same page.
They don't have to be.
This is a little bit, I don't know, first time through can be a little bit sketchy. All right, all you need to look at is the number in front of the x squared. That tells you everything. It doesn't matter anything after that. It just tells you how wide or narrow. So identify which of the following graphs is narrower. All right, let's see. This is Filioki. What do you think for number 1? Is it f of x or g of x? F of x, because 2 is bigger than 1, which would be in front of here. So all you have to do is put f of x. That is narrower. Okay, it's going to be skinnier. Skinnier. For number 3, you got 4x squared and negative 1/3 x squared. Which one is narrower? Narrower. Isabel Card, what do you think?
The first one.
First one, because 4, just ignore the sign. The sign only tells you which direction it goes. 4 is bigger than 1/3. So that means that's going to be narrower for that one. Okay. Let me get that out of there. Whoops. All right, using the graph of f of x equals x squared as a guide. So basically, we're starting with this one right here. How does that move it? Describe the transformation. Describe how it moves, and then you got to tell me where the vertex is. What is that x squared minus 2? What's happening there? Laney, any ideas?
Down.
Down how far?
2.
Down 2. That's all. So all you got to do is it moves down 2. What's the vertex? Okay, anybody? What's our vertex at? If it moves down 2. What's that? 0, -2. 0, -2. Okay. For number 7, we're just going to keep going down. Number 7, h of x equals x minus 1 squared. All right, Styles, what's happening on this one?
I don't know.
You don't know?
Mhm.
Okay. Parentheses, if you have them, that moves it left and right. Any numbers after it, move it up or down. So for this one here, since you just have a parentheses x minus 1 squared, let me do this. If I make this x minus 1 squared and I graph it, usually it starts at 0, 0. You're close enough. You can see it moved over which way?
To the right one.
So it's going to move to the right one. That's all that's going to do. The parentheses are going to move it left and right. So it's going to move to the right one. All right, what's the vertex then, Cindy?
0, 1.
Not 0, 1. Be careful.
1, 2.
1, 0. 1, 0. Vertex. One, 0. All right, if you got parentheses, x minus 4 squared, the x minus 4 squared moves it left or right. Then you got minus 3, which moves it up or down. Okay, Sophia Proust, what do you think?
Right 4 and down 3.
Good. So minus 4, it always goes opposite here. So it's right 4, down 3. So if I graph that, x minus 4 squared minus 3. What's the vertex? Justice, what do you think?
I have no idea. I'm very confused.
Okay, hold on. Here's our normal graph. We said this one got moved 1, 2, 3, 4 to the right and down 3, like this. The vertex is usually at 0, 0. So if that point has been moved to the right 4 and down 3, what are the coordinates of that new point?
That'd be 4, -3.
4, -3. So that would be the answer, 4, -3. All right, you got to be careful here for number 11. Do you have a parentheses squared? No, so it does not move left or right, which is the way the only one this one moves. Of 7. What does a 3 do, however? It makes it narrow. So this is going to be narrower than y equals x squared. All right, what's its vertex, though? It's only been moved up 7. Zane, what do you think for the vertex?
0, 7.
0, 7. Good. 0, 7. Okay, now this next one. And this is one I wanted to make sure we really do because it's going to be confusing the first time. Identify the coordinates of the vertex, and then we're going to make a table of values using the vertex at 2 points to the left, 2 points to the right. We're going to graph it. First thing you want to do is identify the vertex, and that is based upon which way it moves. This moves it left 3, down 4. What will the vertex be? Okay, Rylan, what do you think?
3, -4.
All right, well, think about this. It's going to be -3, -4. Because this one moves it left.
Oh, yeah.
It's going to be the opposite. All right, don't get ahead of me here. You're going to make an XY table. -3, -4 is going to be in the middle. Okay, -3 and -4 is going to be in the middle. All right, think about X values. If this is -3, -2 and -1 are to the right, -4 and -5 are to the left, right? I want -3 to be in the middle. So I'm just going to list these in order. Okay, -1, -2, -3, -4, -5. So I got to have -1, -2, -3, -4, -5. All right, plug those in and see what we get, and then we have to graph it. You should already know the Y value. You can still plug in -3 into your calculator, but you better get back -4 to kind of confirm. So you got parentheses, -1 plus 3 squared minus 4. Okay, I got 0. All right, so put that down. All right, you plug in -2, plug in -3, plug in -4, plug in -5. All right, what do I get when I plug in -2? Angelina, you got that? It says -3. Okay, when you plug in -3, parentheses, -3 plus 3 squared minus 4, you should get back -4. All right, Emily Niedermeyer, how about -4? What'd you get? -3. And Riley, did you plug in -5 yet?
Yeah, 0.
0. All right, let's plot all those points. -1, 0. -2, -3. -3, -4. -4, -3. -5, 0. It's a parabola. It opens up. Okay, there you go. But here's the key. You've got to find the vertex and figure 2 points of, greater than it and 2 points smaller than it for that. All right, your only assignment is do the right-hand side. Do the right-hand side. You might want to start with this one down here. Okay, 14. It might not be a bad idea to start with that one and work backwards.